Okay, so, I said Venn diagrams were very useful for determining validity with categorical statements. So how do we do this? Well, let's take this one. All A are B, no C or B, no C or A, right? Well, how are we going to do this? Well, up until now, we've, used two circles, but now, well, if we have a C here, we can use three, right? A, B, C. So we don't know what these things are, but we have an argument, all A or B, no C or A, no A or C, right? Now, how are we going to do this? What we're going to do is we're going to look at these premises, right? We have two premises and a conclusion. We're going to be doing syllogistic logic for the next couple weeks. Syllogistic logic always has this basic form, two premises, conclusion. It can be a little more complicated. We'll talk about how that's built in, but this is the basic way it works, right? Well, all right. We're going to draw what these two premises say, and then we're going to see if the conclusion's true, right? Well, the conclusion being true would mean that there is nothing in this A category that's not also in C. All of A would be blacked out, except for these two places. You can see where it overlaps with C. Well, is that what our diagram is going to look like? So, all A are B. Well, how do we draw that? We black out everything in A that doesn't overlap with B. Every single part of A here that doesn't overlap with this B circle gets blotted out, right? If you guys want to, you can do this. I think it's sometimes helpful to do it, right? Let's make sure we've labeled this so we know what it is because we blacked out where our A was drawn. As you're getting used to these, it might help to, um, it might help to check off the premises as you've drawn them. Okay. All A or B, no C or B. How are we going to model that? Well, we'll take this whole section here where C overlaps with B, and we'll fill it in to show that nothing can go in there. Well, no A or C, what would that mean? That would mean that every place that our A circle overlaps with C is blacked out, that there's nothing can go in there. Well, where does A overlap with C? Well, right there, which we've already blacked out with our first premise. And also this little sliver here where A, B, and C all overlap. Well, we blacked that out with our second one saying no C or B. There is nothing left that's open where A overlaps with C. We know that this is a valid argument, right? I'll circle it. This whole section here where A overlaps with C has been completely blacked out. Nothing could go in C and also A. Nothing could go in A and also C. Valid argument. All right. Another argument. Again, we separate out our premises from our conclusion. I'll give you guys like the little three dots here. Just a symbol indicating conclusion. We'll do that more. So again, you're going to get sick of drawing this because you're going to do it so much, but you know, it is useful. We draw A, B, and C, and we have to draw it like this. We have to make sure there's a spot where A overlaps with B, but not C, right here. We have to make sure there's a spot where A and C overlap, where B doesn't overlap. All the circles have to overlap at least once, but there has to be spaces where they don't overlap, right? Venn diagrams have to look like this. So we'll go on and label them. And we just start working through our premises, right? Well, no C or B. What's that going to look like? Well, we overlap. Sorry, let me get sloppy here. Let me get rid of this little dot too. All right, no C or B. So we anywhere that C and B overlap, we color in. Well, that's going to be this whole thing here, right? No C, B. And we can just check this off to show that we've built this premise of the argument into, our diagram. No B or A. Well, no B or A, how do we fill that in? Well, where A and B overlap, that hasn't been filled in yet. So all A or C. What would it mean for all A to be C? It would mean that there is no circle left. There's no place to go in A that doesn't go in C. Well, that's not true, right? There's all this stuff out here. There's this whole huge space still left open for stuff to go in A that doesn't go in C. This is not a valid argument. If it were valid, which it's not, then all this in A would have to be blacked out. It's not, so we know it's not valid. This is what no A being in C would look like. That's not what we have. So not a valid argument. All right, let's do a couple more. So all B or C, no A or C, so no A or B. All right. Again, we will draw our three circles first. A and B. There has to be a space where they overlap. There has to be a space where they don't. Venn diagrams have to look like this. C, there has to be a space where C overlaps with A and not B, where C overlaps with B and not A, and a space where it overlaps both, and a space where it doesn't overlap either, right? Any Venn diagram with three statements is going to look like this. Well, maybe more neatly drawn, but this is the idea of Venn diagrams for categorical statements. All right, so let's start evaluating this one. All B or C. Well, what's that look like? Well, that looks like we black in all of B that's not in C. I might not be too careful about this. You guys get the idea, right? All B are C. We show that there's nothing in this. All the B space that doesn't overlap with C, we fill in to show that there's nothing that can go in there. All right. Check. No A or C. Well, how are we going to take care of this? All right. Oh, wait, I have to blacken more B, right? Sorry, I was about to draw a bad diagram. I have to blacken this part because this overlaps with A but not C. So now I've taken care of premise one. No A or C. Well, how do I show that? Well, I have to black out this part here where A and C overlap. Ta-da! So no A or B. Is there any space at all where this A circle overlaps with B that has not been filled in? Could anything fit in here? No, right? You guys can see here in the middle where A overlaps with B, all filled in. The space where A and B overlap is blank. This is, in fact, a valid argument. No A or B just means there's no place where A and B overlap that hasn't been filled in. Well, that is true. Valid argument. All right, one more. A, B, C, right? Remember, always A and B have to overlap. C has to overlap with A but not B in one place, and B but not A in one place, and it has to overlap with both in one place, and there has to be a space in C that doesn't overlap with either, right? Venn diagrams, very, very strict rules on how to draw them and how to use them. All right. All A are B. All right. We have our two premises. Now we're going to model them. We'll draw them into our diagram and see if our conclusion is also true. So all A are B. Looks like that. All B or C. Well, what are we going to do then? We're going to black out all of B that's not in C, right? Well, this section here is not in C, so we black it out. All this over here is not in C, so we black it out. Is this a valid argument? Sorry. So all A are C. Well, if all A are C, it means that there's nothing there's no place where anything could fit in A that is not also in C. Well, what's the only part of A left open? Well, the only part of A left open, I'll just highlight it, is this here. I'll draw it in pink. Well, and this only part of A left open, well, it also overlaps with C. So all A or C, the only way something could go into A is to go into this, well, pinkish part, fuchsia, whatever you want to call it, that I have not blacked out. Well, if it goes in there, it's also going to go in C because you see it overlaps with the C circle. So this is a valid argument. Hopefully you guys are starting to see why these Venn diagrams are useful. Now, one thing you're going to notice is that I did not do any some or some are not statements. Why not? Because those get a little more complicated. Those you actually have to think about a little bit more. We'll talk about that in the next lecture. All right.